after all that hardware playing around, we have Mr. Charles Merriam doing programming for the One Laptop Per Child laptop.
And I had all these beautiful slides, too. So my name is Charles Merriam. I'm going to talk about the One Laptop Per Child project in terms of programming your first application for it. And it's going to be a little difficult without slides, and hopefully we'll get slides halfway through. The slides will be up on my webpage later, which you'll see on the slides. So the One Laptop Per Child is just an amazingly cool program. And I think most people have seen, the nice little green laptops, and they're pretty and they're cute. And when you pick them up, you can tell that this is the sweetest piece of hardware that you've seen for a while. And so when you think, why should you program for the One Laptop Per Child project? A lot of it is, the hardware is really sweet. You deploy to hundreds of thousands of kids. I mean, how cool is that? Most of the stuff we make never sees the light of day. And it's good for you. It's just a good thing for you to start, making internationalized, localized programs using a high GDK system with demessaging and all of these other pieces of Python that you might not otherwise get to. That said, starting to try to develop anything for the One Laptop Per Child project is going to be starting with an activity. Now, this does mean that you're working on top of a nice, solid piece of hardware, pretty good operating system and firmware, pretty squishy shell and developer's environment, but you can still make something cool. As you go through this, your first activity is going to introduce you to what is in that system. And if you want to go forward from there to try to do any systems work, I'd still recommend that you start by working with an activity. When you want to look at an activity, the first thing that's going to surprise you is where your time is going to break down on this activity. You would expect to say, oh, well, you start up and you get a Hello World program going. And that's not going to happen. There's going to be a little bit of front load, and so don't get discouraged. If you look at this nice pie chart, what we have is we spend about 15% of the time you're going to spend hacking on your Excel before you even start. And you're going to be doing this in terms of system administration for your Excel. You don't have to do this, but it's there, and it's a Fedora core, and you have a terminal, and you have Yum, and you can install things, and it's a limited memory, and you can decide what to install. And you're going to end up spending about 15% of your project time sitting around trying to decide what to put on this and how to play with it. And probably you'll end up flashing the ROMs to some newer update because people will tell you scary things might happen otherwise. You will probably go through and update the sugar shell at least once, to probably more than that. Because after all, newer is good. So even if it's last night's very buggy build, you'll be saying newer is better, so I should be developing on top of last night's buggy build, which will take you a little while to get around not doing that. And you'll also end up applying for what's called a developer's key. That means that you can run on last night's really buggy build, even though you probably don't want to. So, accept it. We're all engineers. We're going to sit and start poking inside. That's about 15% of your time. 35% of your time, a third of it, is likely to be spent setting up your development environment. For people who have been working on this for months and months, that used to be closer to 85 or 90%. It's 35%, and it's going down rapidly. The basic pieces of advice I would give you are just use somebody else's precompiled system. I know that just like in the early days of Linux, people said, oh, you're not really developing an application on Linux unless you're building the kernel yourself every day before you start writing something that runs on Linux. And this attitude is still going to be pushed around a lot on the one laptop per child, saying you should go and get all the sources to sugar and build it yourself. Now, you don't have to. There are some precompiled versions out there. It's still a little bit myth as to how to get an emulator running on your laptop. So you can start by running an emulator on your laptop. It will take you some time. If you're working on the XO itself, you'll probably want to put on a keyboard, a USB keyboard to save your sanity, as well as picking out a decent editor. For example, the VI that's installed on it does not have syntax highlighting, and you'd have to just use Yum to pull down packages. Once you've done that, go find some version control. Especially on something that's a little squishy like this, you want to keep things in a version control system so you can put them back and forth. Don't try to get it from OLPC. They do have a big version control, but that really starts after you've been writing your first activity for a while or get someplace. So just pick one of your favorite free SVN suppositories and use that. So then you're going to want to turn around and you've almost got it going, and you're going to end up starting to play around with it. You're going to have to find some cycle where if you're editing, you can quickly test it and then push it down to the XO. Usually on the XO side, you'll do something like a quick SVN update, followed by launching it from the command line so that you can see what's going on. Then you change it back on your laptop and you pull it down again. You can SSH out of the XO box. I don't know anyone who's managed to SSH into it. I'm sure it's possible, but all things are possible. So, excellent. Okay, recapping. Look, it's a laptop. CharlesMerriam.com is where you'll find all the slides starting about tomorrow afternoon. Why you do it? There are a lot of kids. Sweet piece of hardware, and it's good for you. And your very first activity. Oh. Okay. So we've been talking about basically the first half. The blue and orange bars there are about half of your total time. Those will go down. And if you decide to put off working on this for 6 or 8 months, a lot of other people will have worked on it, and those should be trivial. We're going to actually have a BOF later today to try to get people installed, and there's going to be an XO sprint that tries to get people's development environments installed. Also, once you get past these hurdles, that's half your time. But it does mean you might spend some time before you see any results. And that's the downside of it. So you're going to hack on it because you can't help but it. You're going to set up an obvious and intuitive build environment. Oh, and you might need to get an XO. If you just start playing around with the emulator and you decide you want an XO, you buy it off eBay. The OLPC tells you that they have a developers program where you submit a proposal. No, they don't have any laptops. You buy it off eBay. Or you scrounge around your friends. Now you'll find where people spend another about 10% of their time on average, and that's trying to deal with the OLPC Foundation, even though they don't need to. They sort of surround them and throw love at them and think this is good. They're small. They're really small. Last I heard, they're under 40 people. They're trying to do shipments to all these countries, and they're really busy. They are focused elsewhere. This is an educational project that happens to use laptops. They're not in the mode of, let's go out and try to encourage 100,000 developers to use our laptops. They're in the mode of, can we get the very basic things to work so that we can ship to some other country? They're going to be focused elsewhere. This means that if you try to subscribe to, say, the developers mailing list while you're still trying to learn to develop activities, it's going to be a waste of time. If you try to go through and, work with, let me set my project up in their source code control system, it's going to be a waste of time. What you are going to find is just leave them alone, learn how to program on this. It's a horde of volunteers and very few people anywhere else. You'll also find you get sucked into everybody wanting to talk about the strategic planning of the OLPC and what they should be doing and why it's so obvious they should be going in one direction or another for some problem that's probably less than 6 months old. You can spend a lot of time on those discussions. You'll find that most of the time, anyone who says, oh, they're kind of with the OLPC project, if you ask, they're not with the OLPC Foundation. They have no special information feed. And no, there is no secret developer's manual that they're just hiding from us. It really isn't written. So now you're going to go off on the sort of learning to program side. And this is going to be about 3 phases, and they're all going to be simultaneous. This means you're going to sort of muck around on this. Probably 15% of your time is going to be taken up with, when you really look at the snake, Python is bigger than most people expected. Very few people have worked their way all the way through the standard library. Very few people have sort of gotten the hang of all the little intricacies of the non-standard libraries. And you'll spend about 15% of your time, which is a good thing, going off and learning about internationalization, which turns out to be about 2 lines of code that you worry about. You'll spend some time learning about whatever pieces of the standard module you haven't used. For example, logging, PyGTK, PyGames, dbus messaging, Pango. I mean, there's a lot of stuff in there. And it's just that because these are actually shipping to highly demanding end users that really don't care about technical things, and yes, their language goes sideways, upside down, and it's got to make noise, and it's got to have colors, you might not have been used to writing these programs, and you'll get to learn a lot more. It will broaden what you know. So remember, this is good for you. You'll also have to start learning all about sugar, which is both the name of the shell that's running on the XO, as well as the name of the API, and used for various names around the OLPC whenever they're talking about software that is not firmware. So it's kind of a bunch of different mounds. The source is there. You're going to get to read it. I used to have a lot of advice for this about how you go off and you learn to program in Sugar, and now I just say, man, Mr. Fletcher did a really awesome tutorial and put together a really good stack of materials for walking you through a reasonably small kind of tic-tac-toe, networked tic-tac-toe program, going a couple of lines at a time and saying, this changed, and you can see the new functionality, this changed. So you get it off vrplumber.com someplace, and it is a very nice way of walking through how to inherit your activities from sugar.activity and why you have to set these properties and how you call the mesh networking stuff, and it goes through all of that. You're going to use the wiki. There is actually a really pretty, well, sorry, on my laptop there's a really pretty good wiki that goes through and collects random information about the OLPC. Now, some of this is very user-based. Some of this is going to be a little bit more towards developer-based. When you see the little for developers only or OLPC, this page maintained by the OLPC team, just ignore those. If you have decent information, add it. It means that the OLPC team might read it. And when in doubt, just add things to the talk page. You'll also have access to the full source of not just the Sugar environment, but most of the applications that have been written. So a lot of this is going to be scratching your head, see how somebody else got around a problem. Then you're going to build your cool app. This is a whole 10% of your time that's going to be shiny new and broken in a strange and new and interesting way. And you'll find fun and terrible corners of the API when you build it. Your networking is not likely to work quite right because There are all sorts of strange issues where if two XOs next to each other are connected to a router and there's a NAT and this and that, oh, it just routes halfway around the world and back for every message. So, you know, on one little overloaded machine, and there might be a 30-second latency. That's okay. Your app will still be really cool. It's amazing what you can develop on these things. They're a little bit underpowered compared to your desktop, but these are full machines that we would have thought were perfectly reasonable development machines 6, 7 years ago. And then you're going to take the dive. If you're going to go from here and dive in more, I'm going to try to, I was going to try to show you a little bit of source. There's also, the source is all just libraries. A lot of people look at this and they think, how am I developing for this? And it's going to be something totally new and different. Well, okay, so the Sugar system has some libraries. And when you want to connect to a network mesh system, it's going to be calling mesh.connect something, something, something. And you look it up and you say, well, the parameters go in this order. And you're not going to have to worry about the gritty details of Bob passed out of view. Once you've built a couple of activities, if you want to go and try to play with that, the source is right there. If you're going to dive on in, there's actually a lot more resources here today to help you dive on in. Titus will be right after this in another ballroom giving a short talk about testing on the XO. There's going to be, after all of the talks today, there'll be a short BOF that I'm running downstairs and just talking about getting the development environment set up and trying to help people. The easy development environment to set up right now is on Ubuntu. That one is kind of straightforward. Windows under VMware is almost straightforward, and after that, it is possible to do it. We're just learning. There'll also be an XO Sprint. You'll see. You want to stand up so people know where to find you? You can bother that person. He promises that if you are a moderately competent Python programmer, or at least have made one program more than 20 lines long, he will help you get a development environment up and start writing something. And if you happen to be Guido and you want to work on something, they'll throw you at some of the harder operating system bugs. So they're working on that. So there's a lot of space here. This is like this sort of random, unorganized fleet, ragtag fleet of volunteers that are just making stuff because it's cool. And it is cool, and it ships to a lot of people. And it changes people's lives in a very positive manner, and it makes you a better programmer. Thank you. I guess I'll take questions since I can't show you code on this laptop.
What exactly is the development process for some of the more learning-oriented applications? Like the, it just came out in the first build, so it's a learning program application. Working with those types of things, existing stuff, you want to add features or patches, all that.
Okay, so the question is, so there's these cool applications, how do I add features and patches? Well, dev.laptop.org has full copies of all the source for those. There's probably not going to be, and there'll be, sometimes people will run a project page, usually in the wiki itself. So you can go through and figure out what you're doing and start talking to the developer, and like any open source project, you're kind of persuading somebody that these are good changes. But you've got the source there, so you can fire it up. It's possible to fire it up in a debugger and walk through and see what's going on in it and just add to it. Having the source there is great. You'll find that the Python programming, shipping of the XO, for those who don't know, there's a Squeak tutorial. Pippy, which is this Python programming language, is coming along. It's sort of an editing environment, and that's the one where ViewSource will hook into the main Sugar build and try to bring up the Python source of whatever you're working on. They're cool. There's Turtle Art. It's just beautiful. A lot of those programs have actually been around for about 10 years and just have never found a platform they ship in quantity. Next question.
So, okay, you said setting up your development environment is the most difficult first part. Do you have any suggestions for where to start out online to read about how you do that.
Yeah, I'd probably make two suggestions. One is that you come down to the BOF at 5, and the second is that you bug Mike starting at 6. Other than that, yes, there is if you go to the developers, I think it's just the wiki/go/developers, there'll be a spot on setting up the virtual machine. There's not enough information. There's a little line in there for Ubuntu that says, oh, and this person has builds. You take those builds and you run it. You'll also see a little section for, there are all these VMware builds out there that show up as VM disks, or VMware disks. And you take whatever the latest stable version, which was number 656, and you install that. There's not enough directions there. That's why it had been so long. Before, nobody had directions, and of course there's this large contingent that keeps saying, oh, you have to build it from scratch. Go get yourself some silicon. Go get yourself some gold. Everything else should be straightforward.
Exactly how different are the networking APIs if you're trying to write something that's going to be running on both maybe a more standard Linux distribution and the OLPC platform?
The short answer is it depends. Networking out to the rest of the world is straightforward. It's about the same. You're going to have some design considerations eventually, like you may or may not have good internet access. There's an emphasis on caching. The difference is that you're using dbus messaging back and forth for a protocol that says, I want to discover friends. So there's basically a little bit of a presence server that's running the ad hoc network, which you can abstract out to the point where you're saying, hi, I'm announcing that I have a game out here. Or you could start saying, well, I need to find out who's there. I need to invite this person separately. I need to do this. There's a lot of examples of how to do it. It's function calls, but it's more dbus messaging. And if you haven't used dbus messaging, well, it would be good for you to go learn. Next question.
Is it really reasonably straightforward to, all right, this is actually a borrowed laptop, and mine is still on the way. No surprise, but I'm not supposed to mess this one up too much for the person who actually it belongs to. So I'm going to mess it up today, and I'm wondering how easy it'll be to transfer what I mess up onto what I get, and then unmess this up.
Okay, well, the short answer is, look, it's a Linux box. And so if you're borrowing somebody's Linux box, you probably don't want to update the version of the OS unless you want to. And otherwise, it's a Linux box. Put it on a USB key. It actually has an SD flash card slot hiding there underneath the keyboard, underneath the screen. Or just SSH out and copy it over. So it works fine. Go ahead and hack on it. Python is already installed. It's the base of the operating system, sugar shell stuff, as well as most of the applications that are cool. Next.
Okay, we got time for one more.
One last question.
Okay, I understand that this is just getting started in understanding how to program, but where do we find programs that will actually help kids out, that actually do something for the program?
Interestingly, okay, the give one, get ones shipped with a full set of nice, clean software, so you can find those, and all of that source. Again, the nice thing is that the source for basically everything that goes on a laptop is available at devlaptop.org, and once you make a nice activity, you should go through the little rigmarole that they have so that you can put your source tree up there as well. It uses Git, that'll slow you down. It uses shared secret keys, that will slow you down. But you can do it, just don't bother till you get there. You can find those. If you make something really cool, people patch it up, and then for some country distribution, they say, oh yeah, that's going to go on that particular country's distribution, and it will get installed. Make it really cool, and they'll do that. Thank you so much, and if you have other questions, you can chat later. Thank you.